Okay, so PN4023, this is the Section 7 walkthrough of my resource and assessment, Carol O'Connor 19242-832. So if you come in a little bit closer, this is the resource I developed. It's on the planes of reference, and basically what it is, it's surrounding rebatment, so something that we use in nearly every question in roof geometry. I used this just because I found it to be a common difficulty that students struggle with. So you can simply just take plan views and take elevations, and students should be able to get a better understanding of what's going on. So if I take a plan view here, it's very easy just to basically students to draft this, get the solution, and then take the plan view, look at the elevation, see how it's got, and that should be pretty clear to them. I also use this kind of resource because it's open, it's applicable to other principles, so maybe like an auxiliary. An auxiliary is very simple to take too. You can take it for multiple uses. So if I go normal to this, I can take different auxiliary views parallel to different stands. So it's applicable to not just rebatment, but true shapes and surfaces as well. So if I go into my assessment, I basically use them principles. Where's my assessment? Yeah, this is the question I created, and there's the solution. So the question, basically, the rationale behind it is part A and B of the question, they're fairly simple. Just looking for neat quality drafting. Part A, find the true length. These are principles the students know. So basically the reasoning behind it is just that students should know it, they should be comfortable with it. It's kind of like a warm-up activity so students can develop confidence. As this question goes on, it gets a bit harder. So students should think this is something that I can do, it's achievable. Going into part C then, it is the true shape. So finding the true shape of surface C, again using rebatment here. There's multiple ways of doing it, but I'm expecting students to achieve quite highly in that part of the question. So it's all principles that they already know, just being applied to different contexts. Part D of the question then, it is basically a problem. A child's frisbee stuck at point A, point X is where the ladder is, and you have to find the shortest distance between the 2 points. So basically the same principles are being used, nothing new, nothing complicated, but the key behind the question is that they understand the words and they apply it to 3D space, and they should be able to work their way around it. This is where the heavy weighting of the marks is, so that's basically that. The shortest distance can be calculated. Remember, scale is 1 to 100, that has to be worked up, but yeah, it's interpreting words and applying it down on paper is what I'm looking for. So